This line introduces the topic. We're using a specific scikit-learn tool, HalvingRandomSearchCV, to find the best settings, hyperparameters, for randomforestclassifier. It's like finding the perfect recipe for a machine learning model. This sets the scene. The goal is to tune a randomforestclassifier using a specific technique. This indicates that what follows is a multiple-choice question testing understanding of the tuning process. Get ready. This gives the specifics of the machine learning task and the parameters involved. We're using the HalvingRandomSearchCV method with a halving factor of 264 initial candidate models to test, and an automatic determination of the minimum resources. The first statement in the multiple-choice quiz. We start by evaluating 64 different configurations of our random forest model. Think of it as testing 64 different recipes before narrowing it down. The second statement. After repeatedly halving the number of candidates, in the end, only the most promising model remains for the final assessment. The third statement. This tests understanding of how many times the model selection process is repeated, narrowing down the best performing models through each iteration. The final statement. We use the auto setting to let the algorithm automatically determine the least amount of computational resources, time, memory, and data points required in the final evaluation phase for increased efficiency. This indicates the beginning of the hyperparameter tuning process. We're setting up our starting values for the algorithm parameters. The HalvingRandomSearchCV algorithm begins its hyperparameter tuning process. It starts with the specified number of candidate models, in this case, 64. Think of it like having 64 different recipes to try for the perfect cake. After the first iteration, the algorithm evaluates the performance of each of the 64 candidate models. It then keeps only the top half, 32, that performed best. It's like eliminating half of the cake recipes after the first taste test, getting rid of the less promising ones. The algorithm then proceeds to the second iteration. It takes the 32 best candidates and evaluates them. Again, it keeps only the top performers, which is half, reducing to 16. This continues the refinement process, another round of taste tests, discarding more inferior recipes. This halving process continues. Each iteration reduces the number of candidates by half. This is controlled by the factor parameter set to 2. It's like iteratively refining your cake recipes. You're continuously improving them, eliminating the poorer ones at each stage. After 6 iterations, calculated using the formula log 64 equals 6, only one candidate model remains. We have our winner. This demonstrates the successive halving technique. It's like getting to that one perfect cake recipe after several iterations of tasting and refinement. This section outlines the step-by-step execution of HalvingRandomSearchCV. The algorithm starts with 64 candidate models, as specified by _n_candidates equals 64 . In each subsequent iteration, the number of candidates is halved due to factor equals 2 . This process continues until only one candidate remains. This is a successive halving approach, and the number of iterations will be determined by the logarithm, base 2, of the initial number of candidates. The search begins by evaluating all 64 initial candidates. This is what is meant by option A. This is the first step. After the first iteration, the algorithm selects the top 32 performing models, half of the initial 64, to proceed to the next round, discarding the remaining lower performing candidates. This halving based on performance continues in the next rounds. Continuing the successive halving, the algorithm now moves to the top 16 candidates from the previous iteration's 32. Think of it like a tournament where half the competitors are eliminated in each round. The top 8 models from the previous round are chosen for further evaluation. We are getting closer to the best model. The number of candidates is halved again, leaving 4 top-performing models. Only 4 contenders remain. Finally, only the top-performing model from the previous iteration remains. This model will be chosen as the best-performing model based on the hyperparameter search within this particular algorithm. This corresponds to the final iteration's description in option B, verifying its correctness. HalvingRandomSearchCV, this indicates the initial number of models HalvingRandomSearchCV will evaluate. It's the starting point for the hyperparameter search. This means, at each iteration of the search, the number of models being tested gets reduced by half. It's a key element controlling the efficiency of the search algorithm. This sets the stage for our problem. We are using a specific machine learning technique, HalvingRandomSearchCV, to find the best hyperparameters for a model. The values given define how the search is conducted. The key is to understand the behavior of HalvingRandomSearchCV with these settings. Because the number of candidates is repeatedly halved, factor equals 2. Eventually only one model remains to be evaluated in the last iteration. This is a direct consequence of the halving process. The number of iterations is determined by how many times we can have the initial 64 candidates until we reach 1 or less. Mathematically, this is represented as the ceiling of the log base 2 of 64, which is 6. This means the search will run through at least 6 rounds of evaluation and reduction. With min_resources set to auto, the algorithm cleverly determines the minimal resources needed, like data points, for the final, most refined model evaluation. This helps optimize the process and prevent overfitting. Here's where our search begins. The algorithm starts by evaluating all 64 candidate models in the first iteration. This refers to the machine learning technique used in the quiz. HalvingRandomSearchCV is a hyperparameter tuning method that cleverly combines random search with a successive halving approach. It starts by evaluating many different hyperparameter combinations, then progressively eliminates the poorly performing ones. Think of it as a smart way to efficiently find the best settings for your machine learning model, saving you time and resources. The question sets the stage. It's a multiple-choice question that tests your understanding of how HalvingRandomSearchCV works with specific parameter settings, namely a halving factor of 2, 64 initial candidates, and automatic minimum resource determination. Let's see if you can crack the code. This statement deals with the number of iterations the algorithm runs. Remember, HalvingRandomSearchCV iteratively halves the number of candidate models. The formula for calculating the number of iterations is ceil log n_candidates log factor, which is ceil log 64 log 2 equals ceil 6/1 equals 6. So yes, there will be at least 6 iterations. Here's where min_resources equals auto comes into play. Setting this parameter to auto means the algorithm figures out the minimum amount of resources, think data points or computational power, that are needed for the final iteration. It's a handy feature that automatically optimizes resource utilization. The journey starts with 64 candidate models that are all tested in the first iteration. This is the starting point of the entire process. This simply states that after each iteration, the number of candidates is halved. This is the core mechanic of HalvingRandomSearchCV, leading to an efficient search for optimal hyperparameters. After 6 iterations of halving, 64 divided by 2 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 equals 1. Only one model remains to be evaluated in the final iteration. This process gradually narrows down the choices, increasing efficiency. This specifies that the algorithm itself will determine the optimal minimum resources for the final iteration. This is a resource-saving aspect of the algorithm.